Okay, hello everyone. So in this video I'm going to teach you how to analyze a circuit that has multiple diodes. I'm going to assume that you already know what the ideal diode model is, which is basically it considers the diode as a short circuit, as an on, if the voltage of the P is larger than the N, and it considers it as an off, an open circuit, if the voltage of the P is smaller than the N. And that's the voltage of the P, and that's the voltage of the N. Okay? And so in this video in particular I'm going to concentrate on multiple diodes. What to do if you have multiple diodes, because pretty much it's very easy to solve a single diode circuit, a circuit with a single diode, but when it comes to multiple diodes it kind of gets more complicated. So I'll give you some ideas in order for you to know what to do, exactly what to look for when you have multiple diodes to decrease the complexity of the solution. Ideally, if you want to solve a circuit with multiple diodes, then you need to consider 2 to the n, where n is the number of diodes in the circuit. You need to consider that many solutions. So for instance, if you have 2 diodes, then you need to consider 2 to the n possible solutions, which is equal to 4. What are these 4 solutions? You consider that both of them are on and solve the circuit, both of them are off, solve the circuit again, both of them are, one is on and one is off, one is off and the other is on. And for each of these solutions you look which one doesn't have any inconsistency. Okay? Of course, when it gets more complicated, 2 to the 3 diodes, so you get 8 possible solutions. You have to, the worst case scenario is 8, so you might be lucky and you do not, out of these 8, you do not, you get you get a consistent solution, like in the second step or in the third step. You do not have to reach the 8, but the worst case scenario is the 8 solutions, 8 possible iterations if you have 3 diodes. Of course, that's a large number, and we want to find out how to decrease this number, how to find out the correct solution, how to eliminate the non-possible solutions, the solutions that I guarantee that they're not going to give a consistent answer, and thus decrease the complexity of the solution. So let's get started with this example. In this circuit, what it's required, we want to solve for the circuit to find V and I. That is the voltage V, and that is the current I that is passing in this direction. We have 15 volts as a voltage source and the negative 10 volts as another voltage source, and we have 2 diodes. Okay? So the first step to solve a problem with multiple diodes is to look at the path that has a diode, and this path has the largest and the smallest value of voltage. So in this case it's 15 volts and negative 10 volts. So these are the largest and the smallest value of voltage that you have in this circuit. So what's the loop that contains this, that passes from the 15 to the negative 10? You have this loop. Okay? So that's from here to here. That's 15 to negative 10. Okay? So this loop contains one diode, which is D1. And the diode has a voltage Vp, which is closer to the 15 volts, and the voltage N is close to the negative 10 volts. Which means that whether this diode is going to be on or off, I guarantee that this diode D1 is always going to be on. Why is that the case? Because Vp is always going to be greater than Vn of diode number 1. Why is that the case? Because even if this diode is off, in order for this diode to be off, we're assuming that I guarantee that it's going to be on. Why? Because if it was off, then it has to be the case that this voltage is very small, to the extent that it is, like, say for instance, negative 15 or negative 20, a number that is smaller than the negative 10, in order for this voltage to be, in order for this diode to be off. But I guarantee that this V is not going to be is going to be always greater than negative 10. How can a negative 15 come to this value? And that's why I guarantee that this diode is always going to be on, regardless of whether this diode is on or off. take the worst case scenario. If this is off, if this is on, this means that this is a 0, which means that this diode is going to be on. If this is off, then this diode is going to be on as well. So in that case, you do not have to search over the 4 possibilities. Okay? So let's draw the circuit. So let's assume that D1 is on. Okay? And let's draw the circuit. And that's diode 1 is on. Negative 10 volts. 15 volts. 10 kilo ohms. And the question is whether is this diode going to be on or off. That's 5K and that is 15K. Okay? So, diode 2, let's consider it to be, I'm not really sure whether it's going to be on or off. It depends on whether this value of the voltage, is it closer to the 10, is it closer to the negative or the positive? Is it going to be positive or negative? So that I can compare it with the ground, right? So let's try to assume that the diode 2 is on, okay? Which means that this value is a short circuit. Diode 2 on. That's an assumption, okay? So you assume D2 on, right? So in that case, this value of the voltage is equal to V, okay, which is equal to 0. V equal to 0, alright? And in order for us to find out whether we are consistent or not, we need to find the current and make sure that this current I is greater than 0. Why? Because when the diode is on, for consistency, we have to have I is greater than 0, which is the current passing from the P to the N, right? So let's find this, the value of this current. What's that current? This is, let's assume that this is I1, and this is, so that's I2. We have to make sure that this I2 is equal to 0, because I is equal to, I is this value. So we know that I1 equals, that's the current that comes into the node, that's from KCL, okay, KCL equation. Current I1 equals to I2 plus I, right? What is the value of I1? Current passes from the left to the right, then the voltage drop is the opposite, and that's the positive at the head of the arrow, okay, which means that 15 minus 0, 15 minus 0, that's the potential difference, over 10K is equal to I1. What about the value of I? We want to find I2, so what is the value of I? I is equal to that, the current passes from the left to the right, and that's the voltage drop, from positive to negative. So plus minus the minus, so that's a 0 minus negative 10 volts over 5K. Okay, so that is 1.5 milliamps minus 10 over 5, which is 2 milliamps, equals to I2, which means that I2 is equal to negative 0.5 milliamperes. Is this consistent? No, it is not consistent. Which means that we have to re-solve the problem again for D2, which is off. Alright? Why? Because we want I2 to be larger than 0 so that the diode is consistent. Okay? If the current is found to be negative, which means that the current is going to pass from the N to the P, from the N to the P, which is not the case. The diode cannot do this. Right? Which means that we have to re-solve the problem. So let's resolve the problem and assume that diode D2 is off. Okay? D2 is off. In that case, this value of the voltage that's an open circuit and the current is equal to 0. What's the value of the voltage here? Voltage here is not 0, okay? I want to find what the value of I is. So I equals I1, so that is the current, passes from the left from the 15 volts to the negative 10. And what's the value of the current I? I equals, so let's do a KVL, let's do a KCL at this node. Current I equals I. That I is equal to that I. What's the value of this I? It's equal to 15 minus V over 10K. 15 minus V over 10 kilo ohms, right? What's the value of this current? Is equal to 15, and that's equal to V minus negative 10 over 5K, okay? So 15, so that's 1.5 minus V over 10 equals V over 5 plus 2. V is equal to negative 2.5, and that's a positive, so negative 0.5 multiplied by 1 over 10 plus 1 over 5, which is a negative value as expected. So that is 3 over 10, so that's 3 over 20 with a negative sign. That's the value of the voltage V, all right? Which is consistent with what we got. Why? Because when the diode is off, the value of the P has to be less than the value of the N, and that's the value of the P, which is less. It is a negative voltage. Okay. What's the value of the current? The current I is equal to 15 minus V over 10, which is equal to 3 over 10, 3 over 20, so that's 15 over 20, 15 minus, so that's 3 over 20 over 10. So you can calculate this I, and you make sure that this value is greater than 0, okay, which is consistent with what we were assuming. Diode 1 is on, right? So the bottom line is look for the path that has the largest potential difference, and assume that the diode that is in this path is going to be on or off depending on its orientation. Okay, and then the rest of the diodes have to be considered one by one. All right, let's have a look at this other example. In this example, we have two diodes, and we want to find out what the value of the V and the I is. That's the I and that's the V. Okay, so in that case, the I is the current passes through the resistor, and this forward path is the largest forward path that has a potential difference, the largest potential difference that could happen, right? Which is 10 volts and negative 10 volts. And this diode passes through this part of this larger loop, okay? So this larger loop, okay? So which means that D1 is going to be on or off. That's on, okay? D1 is going to be on. Why is that? Because it's in the larger loop, right? And its orientation is towards the P is towards the 10 volts and the N is towards the negative 10 volts. Okay? And even if this diode was on or off, we do not really care, because if it was off, then we do not care. Still, the diode 1 is on. If it was off, if it was off. If it was on, then this is a short circuit, which means that this is a 0, and this makes D1 on as well. All right? So let's have a look here. Let's draw the circuit again, and that's a short circuit. Okay, that's a short circuit, and that's 30, and that is 10K. This is 10, and this is negative 10. Right? So before I draw this diode, I know that this is a 30 and this is a 10, which means that if this, let's assume for instance that this diode was off. Okay, this diode is not really in the circuit. It's an open circuit. Then then this is going to be the entire circuit, right? Okay, and that's the ground. And if you look at the potential difference, what's the value of the voltage here? It's a voltage divider rule, and this value is going to take, this resistor is going to take the higher value of the voltage, which means that this node is not going to be 0. If this was a 10K, then this is going to be 0 volts. 10K and 10K, that's in the middle between that's 10 volts and that's negative 10, then that's a 0. But when this is 30, when you increase this resistor to become higher, it gets more potential difference. The voltage drop across this resistor is higher, and thus this voltage becomes a negative value. Okay, which means that this diode is going to be off. Why? Because this is a negative value compared to the 0 is an off. So there really is a way, even if the diode is not in the path that has the largest potential difference, there is a way to expect and anticipate what the diode, how the diode is going to be. Is it going to be on or off? Okay, so I'm going to assume that D2 is off. That's an assumption. Alright? This is a fact. I know this. I do not have to prove it because I've already proved it. It's already in the forward path. In that simple circuit, it's really easy to decide that D1 is going to be on. But D2, that's an assumption. Okay? That is an assumption. So let's solve the circuit. 10 volts, what's the value of V here? V, and what's the value of the current I here? This is I1, this is I. I1 equals I. So KCL, Kirchhoff current law. The current passes from top to down, so that's from bottom to top. Plus minus I1 equals I. What is the value of I1? I1 equals 10 minus V over, let's see, over 30K. Okay? And what's the value of the I? Current passes below to the top, and that's the value of the voltage, right? Plus minus V minus negative 10 over 10K. Okay? So that is 1 over 3 minus V over 3 equals V over 10, 30 plus 1. Okay? So V is equal to 1 negative 2 over 3 multiplied by 3 30 multiplied by 1 over 30 plus 1 over 10. Okay, so there is a mistake here, and that's supposed to be power negative 1, right? This is supposed to be power negative 1, okay? 1 over 10 plus 1 over 5. So you calculate this, and still this is a negative value. So you do the math, and still this is a negative value. V is less than 0. Okay? And this makes the value, so since this is negative, still this equation holds, right? So, what do we have here? So 1 over 3, so that's a negative value. value is negative 1 over 3 plus 1, so that's 33, 3 plus 30. So you calculate this is going to be negative, well, less than 0, which is consistent with what we have. What is the value of the V? V is equal to 3, negative 2 over 3, 1 over 10, 3 over 10, so 0.1 plus 0.3, 0.4, negative 2 over 0.4 over 4, so that's 20 over 4 equals negative 5 volts. Right? What is the value of the current I? I is equal to V plus 10 over 10k, which is this value, right? So that is negative 5 plus 10 over 10, which means that this is 5 over 10, which is 0.5 milliamperes. Okay? Which means that still this I is a negative, is a positive value, and this is this doesn't have to do. I is positive value, but even if it was negative, we do not care because I is the current that passes through the resistor. We do not care if it's a positive or a negative, right? So let's solve another example. Okay. Okay, so in this last example, I'm going to solve it not using the ideal model. I'm going to solve it using the CVD model, which is the constant voltage drop model. What does that model say? It's pretty much the same as the ideal model, but the rule, instead of you comparing the VP minus Vn to 0, you compare it to 0.7 volts. And the VP minus Vn, compare it to 0.7 volts, and when it is less than the diode is off, and when it is higher, then the diode is on. Okay. Again, similarly for consistency, you make sure that the I is greater than 0, and for when it is off, you have to make sure that the VP minus Vn is lower than 0.7 volts. Right. So the diode, when you replace it, when it is off, you replace it with an open circuit. Right. Pretty much the same as the ideal model. But when it is on, you replace it with a battery. And the battery, the polarity of the battery, the positive is at the P, and the negative is at the N. That's the P, and that's the N. And that's how I remember it. Okay, so that's P and N. Okay, that's an easy way to remember the polarity of the diode. The positive at the P and the negative at the N. And its value, the value of this battery is 0.7. And the current is defined as passing from the positive to the negative, and its value has to be larger than 0. Okay? So, let's solve it using let's solve this problem using the constant voltage drop model, and we want to find the value of V and the value of I. Again, as usual, you look at the path that has the largest potential difference between the 10 and the negative 10, or 10 and the negative 20. Actually, it's the 10 and negative 20. So this path has the largest potential difference. And that's why you expect that D2 is going to be always on. Alright? Why? Because D2, most likely it's going to be, the VP of D2 is going to be higher than Vn of D2. Okay? So D2 is on. Okay? And we're going to assume D1 is off or on. We do not know. However, you might be able to anticipate, you might be able to kind of think that, yeah, let's calculate and find out, is it more likely to be on or more likely to be off? The expectation is that it's going to be on. Why is that? Because you expect that if this was off, okay, this was off, then in that case you expect that the value of the voltage here is going to be, roughly speaking, between the 10 and the negative 20. which is why? Because the voltage drop over the 10K is going to be equal to the voltage drop over the 10K. So the difference is going to be in the middle, the potential difference is going to be in the middle, so in that case this V is going to be in the halfway between the 10 volts and the negative 20, which is expected to be, roughly speaking, negative 5 volts. Assuming that, of course, that these calculations is not correct, because the D2 is going to be replaced not by a short circuit but by an 0.7 voltage source, but roughly speaking that's a good estimate. Okay, which means that the negative 5 is higher than the negative 10, so the diode here is going to be on. Okay, so it's going to switch it on. Once it's switched on, then you expect that the voltage drop, this voltage drop will change. Why? Because there has to pass some current here, so the current is going to come either from this side or from this loop. Then in that case the voltage, there will be some change in the potential difference over these two resistors, and thus this potential difference is going to change. So it's not really going to be negative 5. However, you know for sure that if this becomes, even when this becomes connected, when this becomes on, then the negative 5, yes, it's going to change, but it's not going to come below the negative 10. Because if it does come below the negative 10 volts, then this is going to be open, and we're going to go back again to the original circuit, which makes it negative 5. So it's going to switch between the negative 5 and the negative and the number smaller than negative 10 volts, negative 15 or so. So pretty much, if you didn't really understand this, if you didn't really get to that conclusion, which is diode 1 is going to be on, okay, you might pick up whatever you want, assume that it's off or assume that it's on, and then figure out whether this solution is correct or not. I'm going to assume that it is off, okay, and the reason is because I want to make sure that this really is not going to happen. I'm going to solve it, because even if you did not, yes, I know that it is going to be on. That's based on, I was able to expect and see that, yeah, do some rough estimate calculations and know that it is on. But even if you were not able to do this, and by mistake you assume that it is off, you reach into a contradiction and inconsistency, okay, and thus you will be able to solve it using the on case. So let's assume that it is off. Okay, diode 1 is off, alright, and in that case we want to replace this with a battery, and the battery polarity is above, and that's 0.7, and this was with an open circuit because it is off, and the I, of course, here, I is expected to be 0, I equals 0. What is the value of V? You can do a KCL at this loop, at this node. Okay, what is KCL? KCL says that the potential difference, the current passing here is equal to the current passing here. Okay, so I1 equals I2. That's I2, and this is I1. Right? What is the value of I1? Current passes from top to bottom, then the potential difference is from bottom to top. Right? And then 10 minus V, okay, so that's the potential difference, over 10K equals the potential difference over this resistor, which is V, so the current passes from top to bottom, so that's the potential difference, positive, negative, so that is V minus this potential difference, minus some number, over 10K, because that's 10K as well. So what is this number? We do not really know what the value of this voltage is, but I know that this value is negative 20, which means that I'm going, if I want to know the value of this point relative to that point, so this is negative 20, if I want to go to that point, if I want to go to this node, I pass by a component, and this component has a voltage drop is equal to 0.7, and the direction of the voltage drop is in the same as the direction of the motion. I want to move from this point to that point. And the direction of the voltage of this battery, which is the component that I pass over, is 0.7. And this direction is helping my value. So it's negative 20, since it's helping me, so plus 0.7. So if it was the other way around, negative plus, so the direction is like this, and this is negative 20, so 0.7. So you expect going up is opposite, is this 0.7, which means that this node is going to be negative 20 minus 0.7. Okay, so you take this number and subtract from it the value of this resistor, but the value of this voltage source. But in this case, we have an addition because it is 0.7 going in the same direction of motion. Okay, so let's solve for V. 10k by 10k, right? 10 minus V, 10, so that's 10 plus negative 19.3 equals 2V. So V equals negative 9.3 over 2. Okay, volts. Right? So do this, if we end up with this value. Okay? So negative 9 minus negative 9.03 is, roughly speaking, is equal to 5 volts. Okay? Is equal to 5 volts, which is, roughly speaking, 4.8. Let's see here, 4.22, that's what, 4.75, roughly speaking, 4.7 or 4.8, okay? So that's, roughly speaking, 4.7, or 4.65 or 4.7, roughly speaking. So that's the value of the voltage V, and with a negative sign, which means that this value is negative 4.7. Okay, so you see that the rough estimate, rough calculation was negative 5, and we were kind of close. Okay, 4.7, negative 4.7 is higher than the negative 10, which means that this diode is wrong to be assumed to be off. Okay, that's a contradiction, and that's why we need to solve this problem using, so that this solution is wrong. Okay, and thus we need to solve it using the other model, which is assuming that the diode is on. Assuming that the diode is on, plus minus, and that's 0.7 volts. Okay, and thus we want to calculate, we want to do the calculation of the current and the voltage. Alright? So let's do, when the diode is on, what do we have? We have I1 equals I2 plus I, and I1 equals 10 minus V over 10 kilos, right? And then V minus negative 20 plus 0.7 over 10 kilos plus I, which is V minus negative 10 plus 0.7 over 10 kilos, right? So 10 minus 19.3, right, minus 9.3 equals 3V, right, and this becomes V equals 10, so So 9.3 multiplied by 2, 2 over 3 multiplied by 9.3 with a negative value, which is 6.2 volts. Okay, so as you can see, this value V is a negative value, right? And we want to calculate the current, okay? So that's a negative value, which means that this diode is going to be on, right? And because that's this value, the diode here was in this direction, so negative value, negative 6 and negative 10, of course negative 6 is higher. And let's calculate the current. What's the current? That's the current I, which is equal to V negative 6.2 minus negative 9.3 over 10 kilo ohms. That's plus and that's plus. So obviously this is greater than 0, and thus this solution is correct. So as you can see, that this problem we were able to solve it in 2 steps, not 4, as opposed to 2 power 2, which is the number of possibilities per number of diodes equals 4. We were still able to reduce the complexity, but if you were able to expect which one is on and which one is off for both of them, then you'll be able to reduce it even to 1 iteration only, not 2 iterations. And as you can see, another point, which is the constant voltage drop model is not different than the ideal model, is not that different. Only the difference is in assuming a battery instead of a short circuit. Okay, so these problems are two diodes. Each circuit has 2 diodes only. I've put in the description a problem with a link for a video where I solve a problem with 3 diodes. And it gets quite challenging when you have 3 diodes, because you need to solve 2 to the 3 iterations. And 2 to the 3 iterations means that's quite a huge amount. But if you, and that's why it's a challenging problem. So if you feel yourself comfortable with these problems and you want to try a more difficult problem, then I urge you to have a look at this video. It presents a challenging problem, and we do not really solve it over 8 possibilities, over the 8 entire circuits. We just I give kind of some ideas of how to find the solution in just 1 iteration, not 8 iterations. In that case, even if it has 3 diodes, you still are able to expect which one is on and which one is off before solving the circuit. Okay, have a look at it, and if you have any questions in any of these problems, and if you have any problem that you need a solution to, please post it in, and I'll be able to help you.